Hello, thank you for coming to my presentation. My name is Dejan Grubišić. I'm coming from Rice University, and I'm working with Brian Austin from Berkeley National Lab. Today, we're going to talk about newly implemented feature of monitoring system-wide information in HPCToolkit. HPCToolkit is a performance tool widely used across national labs that help us identify performance bottlenecks and helping us solve them in large-scale applications. So far, HPCToolkit was collecting profile and trace data from our application, which are basically how much time we spend in our CPU functions and GPU kernels, and trace data which help us align them in a timed fashion. From now on, HPCToolkit supports monitoring system-wide information on GPUs like GPU power consumption, GPU temperature, and GPU utilization, and set them up in a timed fashion as well. For this, we used Nvidia NVML library, and our overhead is around 3.3%. So let's see first how HPCToolkit is working. HPCToolkit consists of 4 simple steps. In the first step, we use HPC run to run our application and collect profile data. As an output, we have 3 kinds of files: profile files, trace files, and from now on, metric trace files, having the information about system-wide metrics and their timestamps. After we have performance data, we are analyzing our code structure from binaries by using HPC struct. Once we have our code structure and our performance data, we associate them to each other with HPC prof. And once we have all of these, we are ready to visualize everything using HPC viewer. So let's see one example that we run. We run Lagos application, which stands for Lagrangian high-order solver, on Core supercomputer on 8 GPUs. And we are presenting here the power usage in the first plot, temperature on the second plot, and trace view in HPC viewer on the third plot across 8 GPU nodes. Here, we are calculating statistical data of mean plus standard deviations and minimum and maximum for each point in time for power consumption and temperature, and we are showing them in first 2 plots. In this example, we can see that this application has like several phases. There is a change in the phase around 5th second and around 10th second, in which application have a rise of power consumption on GPUs and temperature as well. So we are able to see in the figure 3 in HPC viewer what is happening with our application across each CPU thread and GPU stream that we are having running. And we can see as well that we are having different stage of the application back then. This all shows us that we are able to associate system-wide information to what is happening with our kernels, and we can examine better and in more detail what's happening with application. We can see as well that this application has sudden drops in power consumption in some points later, and we are able to examine this in more details in HPC viewer. As another use case, we also run back-to-red application on 40 CPU threads and 40 GPU streams, also across 8 GPUs. And we can see here for the 1 GPU, there is like a slight drop of utilization and at 46th second from 100 to 99. And we were curious to see what happened then. And once we zoom in the view for that GPU stream in HPC viewer, we were able to see this drop of GPU kernel offloads, which is responsible in drop in utilization. We can use these to examine different metrics in much more complex application by using this. As a conclusion, we can say that HPCToolkit is now able for monitoring system-wide information. We are using statistical data to show all execution across all GPU nodes on just one graph, and it showed useful to us to examine the extremes. And by the end, we are able to use trace view to zoom in and to see what is the problem with our application. With this, I would like to finish my presentation, and thank you for your attention.